Okay, I got some more implicit differentiation problems because practice makes perfect. So we'll just pick up where we left off in the last video, and we're just going to take the derivative of each of both sides. So derivative of 1, well, that's 0. Derivative of 2x, that's 2, minus derivative of 3y squared, that's just 6y, and remember dy dx. Okay, so let's see what we can do here. Let's add 6y times the derivative to each side. Okay, we'll add to both sides and we end up with 6y dy dx equals 2. So we just go 6y. We divided by, we just took that out. And that should leave us with 1/3 over y is the final on that one. So there's that one. Okay. Let's do another one. Let's do one with a trig function. Let's go 2y squared equals x squared plus cosine xy. Okay, so we get this one. This might be a little tricky. Let's take the derivative. Let's just write this one out. dx squared equals okay, so we did that. So we're taking the derivative of each one. So derivative of the first one, now that's going to be 4y squared dy dx equals, that's just 2x. Derivative of cosine xy, that's going to be, this is going to be the trickier one. So that's going to be equal to negative sine xy times the derivative of inside. So let's just go ahead and we'll go negative sine xy, but it's also going to be multiplied by what's on the inside, and that's a product. So this one's actually going to get kind of messy. So how am I going to do this? Actually, what I'll do, I'm just going to do this part separate. Let me just figure out what that is for now. Okay, because the other ones are easy. So that's going to be equal to negative sine xy times we're going to do the derivative on the inside. So derivative of f, that's 1, times g is y, plus derivative of g, that's dy dx, and regular x. So this is equal to negative sine xy times y plus x dx, dy dx, sorry. So that's where that goes. So let me just take these two things and put them back down there. So that's 4y, actually I messed up there. It's 4y dy dx equals 2x minus y sine xy plus x dy dx. Is that right? Okay, yeah, it was 4y dy dx plus 2x plus a big mess, and I just went ahead and did that separate so I didn't run out of paper, and then I just tacked it on later. So here we are. here we are, and I want to get dy dx, so let's just subtract x dy dx from both sides. And that should give me 4y minus, ooh, I'm gonna run out of paper again. Man, this thing's this is a big one. So let's see here. I am subtracting. I'm solving for dy dx. So let me go ahead and do that. I'm gonna rewrite over here. So that's 4y dy dx minus x dy dx equals 2x minus y sine xy. Okay, so that turned out to be what's going on there. I am going to factor a dy dx out of here. Okay, that's equal to 2y. Okay, then we got that. So let's divide by 4y minus x, and dy dx should end up giving us exactly that. That's okay, so that should be it. Okay, if I didn't make a mistake somewhere, but it's, yeah. So that one was kind of tough. That took some time and some messing around. So if we go back over it, we ended up here. We just took the derivative of each one. Bada bing, bada bing, bada boom. We ended up with 4y times dy dx equals 2x, and then this derivative ended up being pretty long, so we just we did it, in one sitting basically, and then we plugged it in, and then we ended up with this guy. And then after that, it was just a matter of treating dy dx just like it was some variable, and we solved for it in the end. And in the end, we ended up with a really crazy looking derivative too. So that's that, and plenty more to come.